My name is Eduard Diez. I'm innovation manager at GTD company. It's a company based in Barcelona. And the topic today for the webinar, it's one of the work packages that GTD has been involved during this project, the SALTO project, the autonomous flight safety system, the software and hardware development and testing that we've done for the Themis. So maybe just to put a little bit of context, since maybe not everyone knows about what is flight safety. Flight safety is the system that is responsible for monitoring the mission and assuring the safety of the goods and people during the mission itself in real time during flight. So as it is today, that flight safety system, it's man supervised, it's human supervised, and it's in the spaceport itself. So when at the launch pad, the launcher flies in ascending trajectory. During the flight, the mission is supervised, it's monitored by different sensors. Normally it's radars and telemetry antennas that download the mission data to the ground and to the operators, to the safety operators. The system processes the data and displays to the operators the necessary information to make the decision whether the flight is being safe or not. It's being nominal, degraded, non-nominal, etc. So eventually, if it's necessary, those safety operators that monitor the flight send a neutralisation comment to the launcher, and the mission is terminated. So that's a very critical system that it's one of the key systems at the spaceport during the flight. So there are three systems, flight safety systems currently in Europe, and the three of them have been developed and are currently maintained by GTD. The first one is the oldest one, which is a system that it's developed and maintained for GTD for the last 30 years at the European Spaceport in French Guiana. With each, now here we're going to go more into detail, but it's more or less what you saw in the image in the left, which is that we have the launcher with different navigation sensors. The information of the launcher, the status of the equipment, and the navigation sensors is downloaded to the ground. And those data are sent safety to the flight safety system in that light blue boxes that is previous to the mission. It's configured and it's trained and it's accepted during the mission analysis, and that safety create the launcher data either for the trajectory for the navigation sensors generates safety criteria. The safety criteria can mean the impact point, impact area. If the launcher is following a nominal trajectory, if it's inside flight corridor, and that safety criteria then it's displayed for the operators, and those operators make their decisions based on their training and send the telecomment. That's the current system working at the CSG, the European Spaceport, and it's been developed and maintained by GTD. Then in the frame of the new space, GTD has been developing and maintaining since 2023 similar system with its own particularities for the Kiruna spaceport and for the Diez spaceport in Norway. So the particularity of that system is that GTD included an autonomous function, meaning that the safety criteria now it's sent to a safety decision module, so algorithms that try to emulate the behavior or the safety rules that the human operator applies for the mission safety. And now those rules can be processed, the safety criteria can be processed, decision making can be done in real time, only with human supervision, but can be done autonomously. Just to make an example of that, the last ISAR, the Spectrum ISAR maiden flight done in the 25th of March this year, it was neutralized with the GTD system in the autonomous mode. So it was then during mission exploitation, it was confirmed that the neutralization was necessary, and so not human trigger, it was autonomous trigger. So those are the other systems that are currently also operating in continental Europe. So what's done or what's new in the frame of SALTO? So we're dealing for now with expandable vehicles, and in the frame of SALTO, the challenge is to deal with reusable vehicles. And one of the keys of reusability is that ground-based flight safety does not allow reusability per se, because when you have an ascending vehicle and some parts of the vehicle make re-entry maneuvers, it can be one just low stage, it can be even a couple of boosters. You have multiple flying objects in the same space area, and they are difficult to track, monitor, and securely or be neutralized at the same time. So that's becoming a problem. And that's also a problem because if we want to do that for multiple objects, and one of the drivers, the new space, to boost the competitiveness of the European space is to reduce cost in terms of not only infrastructure on ground, but also for the operations on ground. Multiplying or having the tracking systems or the flight safety systems for multiple objects, that definitely do not contribute to reducing the cost and the operations for the ground. So since the launcher itself is an autonomous vehicle, it's not controlled or guided by any human, it's controlled and guided by itself. The challenge here is to increase the launcher autonomy by moving the safety criteria and the safety decision-making from the ground and even autonomously and supervised by a human to put them on board the launcher. So to make the launcher fully autonomous and make their own decision safety. That allows that any multiplicity we have, any multiple flying objects we may have in the space, so the re-entry viewable vehicles and the ascending vehicles, all of them can have their own, they are enabled to make their own safety decision. One collateral consequence of that is that you can see the white boxes, radar antennas, the processing systems, operators and training of the operators, the IT systems for the flight safety, the telecom antennas, the reception antennas of the launcher. All those white boxes are reducing of infrastructures and operations for the flight system. So if we want to move to reusability, we have to pass through the onboard autonomous flight safety system. And that's what GTD has been contributing to the SALTO project for the last 3 years. The most important thing for reusability, since we're moving from expandable to reusability, is that it's not only important now to track for the safety of the mission and the goods, the dynamics of the launcher. It's also important to monitor and to diagnose the equipment of the launcher, because you cannot make a safety re-entry if, for instance, an actuator of the rocket engine is damaged, or you cannot make a safety re-entry if you don't have the aerodynamic surfaces that can control the re-entry. They are not working properly or they are damaged. So we have to monitor as well the equipment to ensure the safety. So that's the big delta, let's say, the big improvement between the software. It's now currently operational at the CSG or autonomously at Kiruna and Diez, but it's also for reusability. That's the big improvement, making also the diagnostics of the launcher with a big contribution then in reusability and autonomy. Then the other part of the improvements of the work is done by GTD during SALTO. It's in a context of very an uncertain context, because most of the launchers, they do not know which kind of system or flight safety system they're going to use. The spaceport, they're still dealing with regulations and they are not really know exactly which kind of regulations they're going to use in terms of autonomy. So we cannot define, or we cannot design or develop something that's fixed, and the final solution we have to build in following standardization drivers and scalability drivers. So that's why most of the improvements that we've done to the system are related to that kind of drivers, which is the library-based module. So meaning that we are not making just a software, we're making a lot of software based on libraries, so they can be then reused in different software. Even the software or the specifications change, most of the algorithms of or the functions can be reused. We also invested in making a missionization tool, meaning that the software can read configurations already when already the software is compiled, meaning this do not need a recompilation or a requalification of the software. The compilation of the autonomous flight safety system can read configurations. We also work in navigation instruments cross-degradation, meaning we do not know how many or which quality or performance of the navigation instruments, the GNSS or universal navigation units, they're going to be on board the launcher. So we work with different variations of that. We also work with costs and redundancies, meaning we do not know how much performance are going to be asked our equipment, or how many of them, of the volume or the mass they're going to be allowed, the power consumption, etc. So every decision made in terms of hardware and software, they are being addressed to improve or to scale once this uncertainty around the flight safety system for the new space and for the future launchers, and above all the reusable launchers, it's being more clear. And so, which is the roadmap for GTD in the coming years. We have already secured, and we think it's targeting in the second quartile of the 2026 to test within the continental Europe spaceport suborbital in slave mode the software version that we've developed in SALTO in a COTS equipment. It's currently under design at GTD. So we target this to test at least that once we can fly that software that we developed in the frame of SALTO to increase the maturity of the technology. Then we have already submitted projects, and we're expecting to be awarded for the test of reusability. For the test of the same software in suborbital tests for usable launchers. Here in the first half of the year of the 2026, the objective is to increase the qualification of the software from Class C to Class B. And the other very important point here is if we want to use reusability for long missions and for in-flight operations, we are trying to boost and to increase the integration vehicle health monitoring module with AI on board in real time. Means that we are partnering with companies here in Barcelona to include our software, to onboard our software in edge computing frameworks, and to onboard also that framework with hardware that enables and to allows that AI on board for the better diagnostics of the launcher. Those two milestones are quite consolidated for the 2026 in our innovation roadmap. And more uncertain for the moment is in 2027, but it's our target as well to try to fully qualify the software for Class B or Class A for the most critical components, and to design and implement a full hardware qualification. And one of the other important topics, aligning with the launcher providers that also are improving their AI prognostics on ground for the refurbishment operations inter-campaigns. We are looking forward to link, let's say, or to interface the diagnostics that we can do on board with the eventual necessity of the AI prognostics or the failure prognostics that the reusable launchers will be needing for ground refurbishment operations. So that's a target for a midterm target for 2027. So that will be all from flight safety. Hope I was on time and expect the questions afterwards.